Hey guys, so this is question number 27 on your correctives. Now, if you're following along and you want to double check your other work, it is a lot like worksheet number 4, question number 4. So you can go back and compare this as being the same thing. So let me just kind of read through here. Now, I will be using some notes here because I think it's a great idea to use your notes as you go through and make some of these videos. So it says, in chemical cold pack, solid ammonium chloride dissolves in water, forming aqueous ammonium and chloride ions. As a result of this solvation reaction, the cold pack feels cold on your injured ankle. So a couple of things that go into this. First of all, thinking of a cold pack. If you've ever been injured before, you grab a cold pack out of a med kit. It's at room temperature. You break it, you shake it up real good, and then it gets really cold. You put it on your ankle, and then eventually it's not cold anymore. So that's kind of our thermal energy consideration. But let's sort of think about what's happening here. So we start off with solid ammonium chloride. So we have ammonium chloride, NH4, which has a +1 charge, chlorine, which has a -1 charge. So those two are going to combine together in a 1-to-1 ratio. No need for any extra subscripts. That's going to break down or dissolve into ammonium, which has a +1, and chlorine, which has a -1. Now, it does say that it's ammonium and chloride ions, so we're going to leave those as individual ions. Since it gets cold, it's pulling energy in, so we know that our energy is going to be one of our reactants. Energy is going to be on the right side as a reactant. So let's go through and see what our bar charts look like. Now, I said it starts off at room temperature and it ends at room temperature. So our thermal account, we're just going to have 2 bars at the beginning and at the end. And in the middle of that, it gets cold. So we know that in the middle of all that, the temperature has to go down. Okay, so our temperature is going to drop. So now we think about the chemical energy. Well, we know that for it to get cold, it has to pull energy in at some point. Okay, and so for it to pull energy in, then that means that our chemical account has to be lower at the beginning than it does at the end. So our chemical count here at the beginning, we're just going to go ahead and draw 1 bar. Our chemical account here at the end, we're going to go ahead and draw 2 bars. So now we've got to determine what exactly is happening in between those. Okay, this of course here has to do with our reactants. I'm going to write this up here. These are our reactants. These are our products. And then this is the product, what's it say here, at the later. Okay, this is after the reaction is all the way finished up. So from our thermal account, that energy is going to go into the chemical reaction, which now means our chemical account is going to go up. This is the point at which the reaction begins to pull in energy from the environment, and now we end up with the final product chemical account. Guys, I hope that helps for question number 27. See you on the next video.